In Objective 4, we're going to venture into the world of graphing log functions. Now, as I've got right here, I'm going to leave it up to your teacher to decide how far he or she wants to go in showing you that the log function is the inverse of the exponential function. But it is worth knowing this, because the exponential graph looks like this. Exponential growth looks like that. And that would be a parent function because it hasn't been shifted left or right or up or down. And if we remember, this point was always 0, 1, unless there was some type of a shift. Well, the log graph is the inverse of this, which means if you thought of the imaginary line of y equals x, a 45-degree line just going right there, this would be the reflection of that, and so it would go something like this. And instead of the important point being 0, 1, as it is on the exponential graph, the important point is actually 1, 0, as it is on the log graph. But again, that's assuming there's been no shift left or right. So let me use that as an example. Y equals log base 7 of x. Now, a lot of times I like to think about it with the y on the other side, so I actually just move the y to the other side, and I think of it like this. Log base 7 of x equals y. Now, if you go on to Desmos, and you just type in this equation and look at what the graph becomes, you're going to see a graph that looks something like that. And the only point that they're going to show you is that very important point, 1, 0. But we're going to use a few other points. Now, since I'm in log base 7, okay, we're going to go back to the way that we almost always figure out how do we graph a function, a line, a parabola, an exponential, whatever. We always start off by picking some points. Now, we can't just pick any points. There are certain points that are going to be really nice. For instance, if I picked the point x equals 7, and I substituted it right there, I would be solving the equation, what is log base 7 of 7? And hopefully by now, you realize that answer is 1. Because anytime, if you're in base 7 and you're trying to achieve the number 7, what power turns the number 7 into the number 7? The answer is 1. Now, you can always go out of log form and into exponential form to get the answer, but, the answer is 1. Anytime the base and the number are the same thing, the answer is 1. So, we know that there is a point, x equals 7, y equals 1, that's a very important point on this graph. Now, another very important point would be, what if I tried to make x equals 0? So, log base 7, and I'm going to substitute a 0 in there for that x, and make that equal to y. So really, what I'm saying is what power turns the number 7 into the number 0? If we take this out of log form and into exponential form, that's actually the equation that's trying to be created. What power turns the number 7 into the number 0? There is no power that does that turns the number 7 into the number 0. So remember when I said there are some nice points and some not nice points? 0 is actually a very not nice point. Okay? There's no way achieving 0. In fact, x equals 0 is the vertical asymptote. So, I know I've got a solid blue line to represent the y-axis, but I'm also going to make it a dashed red line to indicate that it's the vertical axis. There's this part of the graph gets closer and closer and closer to x equals 0, but it never touches. Okay, so what are some other good points? Well, how about 1? It'll work. If I plug the number 1 in for x, then I would be using the equation log base 7 of 1 equals y. So the question becomes, what power turns the number 7 into the number 1? Or if I took it out of log form and into exponential, the equation would look like that. And we know what power does that. Anytime you raise anything to the power of 0, you get 1 as the answer. So 1, 0 is the answer. The power that turns the number 7 into the number 1 is 0, because 7 raised to the 0 is 1. So that means 1, 0 is a really important point right here, and that's the one Desmos probably shows you. Okay. And remember, that's the one I showed you up here on the parent graph before we did any shifting, because there's no shifting here at all. I'm going to do another one after this that has some shifting. Now, the other nice point would be 1/7. I'm going to plug the number 1/7 right in there for x. So the equation would be saying log base 7 of 1/7 equals y. And now the question is, what power turns the number 7 into the fraction 1/7? So I'll go out of log and into exponential just to show you what I'm talking about. So what power of y turns the number 7 into the fraction 1/7? That's -1. So that would be another point on the graph. So there are 3 points on the graph. X equals 7, 1. So probably, somewhere around right here. 7, 1. And then 1/7 when x equals 1/7. So I'm barely going off the origin, but I have to drop down to -1. So who knows, it would probably be, if that's +1, let's call this -1 right here. So it's on that graph, really close to the x-axis, but not touching, because remember that's, or the y-axis, because remember that is not only the y-axis, but it's also a vertical asymptote. So we'll say that this x value is 1/7 and its y value is -1. So there we go. There's what the graph looks like. Now, the next part of the problem, or the example, asks a few questions about this. For instance, here's the equation again. What would be the x-intercept of this graph? Well, if we go back and look at the graph itself, we know where the x-intercept is. It's 1, 0. But just to show, remember how we find the x-intercept. We set y equal to 0. So let's do that. Let's just set the value of y equal to 0. We'd have log base 7 of x equals 0. Now, let's solve this by going out of log form and into exponential form. 7 raised to the 0 power equals x. Well, 7 to the 0 power is 1, so 1 equals x. So that's the x-intercept. When x is 1, y is 0. But our graph told us that anyway. Now the y-intercept, set x equal to 0. So let's go back to the same equation again. Log base 7 of x equals y. And this would be log base 7 of 0 equals y. Let's try to solve this by taking it out of log form and into exponential form. 7 to the 0 power equals, 7 to the y power. I'm going out of log form and into exponential form. So, 7 to the y equals 0. Now, what power turns the number 7 into the number 0? There is no power, no solution. So what we just figured out was there is no y-intercept to this graph. It never does cross the y-axis. And that's what our graph told us too, that it gets closer and closer and closer and closer to the y-axis, but it never does cross the y-axis. Now, the domain of the graph. And the graph itself is going to help us. Okay? The lowest x this graph uses is 0, but it doesn't actually use 0 because 0 was the vertical asymptote. So 0 to positive infinity. Okay. The lowest x it uses is 0, but not touching 0, but it uses all of the other x's going that way. Now, the next question is going to be the range. What's the lowest point and what's the highest point? Well, this just keeps going lower and lower and lower forever. Now, this keeps going higher and higher and higher, but it never flattens out perfectly, but it gets closer and closer to being flat, so it takes longer and longer and longer to start to keep going up and up and up. But it does. It goes lower and lower and lower forever, and it goes higher and higher and higher forever. So the range of this graph would be from negative infinity to positive infinity. Now, the vertical asymptote. Okay, well, again, we've already determined the vertical asymptote a long time ago when we made our graph. Okay, the vertical asymptote is the y-axis, so that's x equals 0. That's the vertical asymptote. Okay, now that's an example using log base 7 of x equals y as the equation. Couple things to note one more time. There's no shifting. I haven't moved it left or right. I also haven't moved it up or down. And it's very similar to problem number 1, except I think problem number 1 on your worksheet uses log base 3 of x. So if you chose 3, 1, and 1/3 as your points, I think that'd help you understand if you're having any trouble with this. The next problem I'm going to do for you is actually problem number 6. So this is a problem that's on your worksheet. Y equals log base 4 of x plus 1 minus 2. So there is a shift going on. In fact, there are 2 shifts. Now, one of those shifts is when x plus 1 is in parentheses, it means the graph is being shifted to the left by 1. But the minus 2 that's right there means it's also going down by 2. So left 1, down 2. But what would help us is, well, what would the graph look like if it hadn't been shifted? What is y equals log base 4 of x? What does it look like? Well, I can tell you what it would look like. It would look something like this. And the one really important point on that graph would be 1, 0. Okay? So if the problem had simply been y equals log base 4 of x, this is what the graph looks like. And remember, there would also be a vertical asymptote on the y-axis at x equals 0. Well, we've got a few things to do to this graph. The first thing we need to do to the graph is we need to shift it 1 unit to the left. Well, what that's going to do is it's going to shift that asymptote. So the asymptote that used to be on the y-axis at x equals 0 is now at x equals -1. And that really important point that used to be at 1, 0, think of what that would do if it was shifted 1 unit to the left, 1 unit to the left, and then 2 units down. That would put it right on the y-axis at x equals 0, and then -2. So 0, -2 would be a really important point on that graph. And then I guarantee you the graph is going to do something like this. Now, I promise you it's going to cross that x-axis at some point because it never turns straight flat. It keeps going up and up and up, but it goes up and up and up at a slower and slower and slower rate. So what would be a few nice points to choose? Well, this is the way I teach my class to do it. What if it was log base 4 of x? Well, that means a really nice point for x would be x equals 4, because we always like to know when log base 4 of 4, what is log base 4 of 4? The answer is 1. Anytime those two numbers match, the answer is 1. Well, I can't if I plug in an x value of 4, that makes this 5. But if I plug in an x value of 3, now I've got log base 4 of 3 plus 1 minus 2. So that's log base 4 of 4 minus 2. Log base 4 of 4 minus 2. Now we know what log base 4 of 4 is. It's 1. So that's 1 minus 2 equals -1. So that means the y value is -1. When the x value is 3, the y value is -1. So if I just estimated it 1, 2, 3, -1, it might be somewhere about right there. Now we also like it when that value is 1, because I know what log base 4 of 1 is. If I was trying to figure out what log base 4 of 1 is, I know what that is. It's 0. Well, what value of x would make this log base 4 of 1? X equals 0. So I'm going to plug a 0 right in there. So log base 4 of 0 plus 1 minus 2. So that's log base 4 of 1 minus 2. Now I know what log base 4 of 1 is. What power turns the number 4 into the number 1? It's 0. So 0 minus 2 equals -2. So when x is 0, y is -2. And we actually already have that right there. And I've got a couple points, and that's really all I need to know. Now, let's find a few things that they might specifically ask for. What is the x-intercept in this problem? Well, I guarantee you there is an x-intercept. This graph keeps going higher and higher and higher. Okay, it's just somewhere we don't know yet. So set y equal to 0. So 0 equals log base 4 of x plus 1 minus 2. All I did was I put a 0 right there where the y is. Now I'm going to start solving. I'm going to move the negative 2 over to the other side, and it's going to become a positive 2. 2 equals log base 4 of x plus 1. Now, you might be wondering, well, what do I do next? I'll bet you anything if I flipped these two things to their opposite sides, you would know. So think of it like this. Log base 4 of x plus 1 equals 2. So just put the equals 2 over here on this side. And now you have an equation that's written with a single log. So the answer has always been, the way you solve it is you go out of log and into exponential. You've done this dozens of times. So the next step for this one in exponential form, this would be 4 squared equals x plus 1. So 16 equals x plus 1. Subtract 1 from each side, 15 equals x. So that's the x-intercept. Eventually, this curve will cross the x-axis at 15, which makes the x-intercept 15, 0. Now, what about the y-intercept? Well, we know where the y-intercept is already, but let's prove it mathematically. In order to find the y-intercept, set x equal to 0. So we're going to go back to the equation, and let's put 0 in for the value of x. So that would be log base 4 of 0. All I'm going to do is substitute. 0 plus 1 minus 2 equals y. Okay, start evaluating. Log base 4, 0 plus 1 is 1, of 1 minus 2 equals y. So what is log base 4 of 1? Well, what power turns the number 4 into the number 1? And that is the power of 0. So 0 minus 2 equals y, negative 2 equals y. So that's the y-intercept. So in ordered pair format, the y-intercept happens when x equals 0, so 0, negative 2. Okay, some more questions about this particular problem. What's the domain of this problem? What values of x are used in this graph or in this problem? Well, remember, the vertical asymptote happened right here at x equals negative 1. So it's all the values to the right of negative 1, but not including negative 1. So the domain is negative 1, but not including negative 1, to positive infinity. And then the range is negative infinity to positive infinity. Now, the vertical asymptote, we already took care of that right from the very beginning when we did our shift. The vertical asymptote is at x equals negative 1. Now, here's a new problem. What would be the average rate of change from when x equals 15 to when x equals 1023? Now, This is really just a matter of slope using these two values of x. And I promise you the numbers are going to work out very nicely. So the first thing I'm going to do is I'm going to plug 15 in for that value to see where y is. Y equals log base 4 of, now 15 plus 1 is 16, and then minus 2. So y equals the log base 4 of 16. What power turns the number 4 into the number 16? It's 2, because 4 squared is 16. So 2 minus 2 is 0. Y equals 0. So that sets up one of the points as 15, 0. But where is y when x is 1023? So I'm going to plug in 1023. So the equation is y equals log base 4 of 1024 minus 2. Now remember I told you I promised you the numbers were going to work out. All you have to do is play around with your calculator for a second. What power turns the number 4 into the number 1024? So, I mean, let's try, oh, I've already done it right here. Okay. See how I was playing around with some numbers? 4 to the 5th power is 1024. So, that's the answer to log base 4 of 1024. It's 5. Y equals 5 minus 2, which is 3. So that sets up the point 1023 as the x and 3 as the y. So now to find the answer to this problem, the average rate of change, now I just do slope. y2 minus y1 over x2 minus x1. I'm going to choose this as my y2, so 3 minus 0. So it would be this y minus that y over this x minus this x. So 3 minus 0 is 3. 1023 minus 15 should be 1008. And that can actually be reduced. This is obviously divisible by 3. 1008 is also divisible by 3. You get 336. And so the answer is 1 over 336.